In this lesson, we're going to learn how to write the equation of lines. In the previous lesson, we learned how to take an equation of a line and then graph it. And now we're going to work backwards. We're not always going to actually be looking at the graph. Sometimes we may just get some points on the graph and we'll have to write the equation. We may be given the equation of a line that the line we're looking for is perpendicular to. So there's a few variations that we're going to have to learn. To write the equation of a line, we're basically going to use the point-slope form. Now, we've already studied several equations of lines, and we've graphed lines from those equations. For example, we definitely have graphed equations in the slope-intercept form. That would be the form of y equals mx plus b. And we learned how to graph lines from standard form, which was ax plus by equals c. But the equation that we're going to use most often when we're actually writing the equation of a line will be point-slope. Now, some of you may have learned how to write the equation of a line using the slope-intercept form, and that's okay, but that's not the way I'm going to show in this video. So let's get started with that. Here's the point-slope form of an equation. It's y minus y1 is equal to the slope times x minus x1. And in this equation, the x1, y1 is a point that the line passes through. Okay? So, the first thing is, let's see, where does this equation form come from? It's called the point-slope equation form. And what it really is, it's just the slope rewritten in a different form. So we know that the slope in that equation is right here. y2 minus y1 over x2 minus x1 is the slope. Well, if I would take and I would multiply this side by x2 minus x1 and the other side by x2 minus x1, those slopes, those parts of the equation would cancel, and I end up with y2 minus y1 is equal to the slope x2 minus x1. And that's where the point-slope form comes from. Okay, now to use the point-slope form, what we need is we need at least one point and the slope, right? Because we can see from this equation, we need the point, x1, y1, right? That would be x1, y1, and we need the slope. So if we have those two things, we can write the equation of a line. When we're done writing that equation in point-slope form, we will always want to convert it back into slope-intercept form. That's just the way we like to have the final equation, because slope-intercept form is a y equals, and that's the way a lot of our other type equations for quadratics are, so we're always going to want to switch it into that form. So let's go ahead and do an example here. We have an example that says find the equation of a line with a slope of 3 that passes the point 1, negative 2. Okay, so here are the things that we know. We know the slope is 3, so that's m. We know the point that it passes through, x1, y1. That's going to be 1, negative 2. So let's plug those into the equation. We have y minus y1 is equal to the slope x minus x1. Plug in the values in. We have y minus, and the y value is a negative 2, is equal to the slope, and the slope is 3, times x minus x1. x1 is 1. Y plus 2 is equal to 3x minus 3. Then to get it into, first let me say that this form right here, this is point-slope form. Okay? But we do not want to leave it in that form. We'll put it into slope-intercept form now. So we want to get this 2 over to the other side. So let's subtract 2 from both sides. And we end up with y is equal to 3x minus 5. That's slope-intercept form, and that would be my answer. Okay, here's another example. And this one, we're not given any points. I mean, we're not given, just given the points. What we have is a graph. And so what we need to do is we need to find some points on the graph that we can put into this point slope form. So what I picked is I picked the 4, 3, negative 2, 0. So for this one, I can say that x1, y1 is equal to either one of those points. It doesn't matter which one I pick. It's just a point that the line passes through. So being that this one point, the negative 2, 0, actually has a 0 in it and may be easier to use, that's what I'm going to pick. So I'm going to call the negative 2, 0 as the point I want to use. And let's find the slope. Okay, so the slope of this line is I can use any of these points. It looks to me like if I start here, I go up 1, that would be in the y direction, then 2 to the right. So my slope is 1/2. Here's my equation. Let's plug the values in. So I have y minus the y coordinate, which is 0, is equal to the slope, which is 1/2. X minus x1. x1 is a negative 2, so that's x minus a negative 2. Y is equal to 1/2 x plus 2. And you can see how having this, using the point with 0, actually made my calculation easier. Y is equal to, distributing the 1/2, I've got 1/2 x, and then 1/2 times 2 would be 1. So that's my equation. Some of the rest of these notes, I'm showing how you could actually use slope-intercept form to write the equation of a line. I want to skip that and just stay with the point-slope form. I also want to talk briefly about the standard form. Standard form was a form that we actually used to plot a lot of lines, but when we're writing backwards, writing the equation of a line, we really don't write directly into standard form very often, so it's really not useful for this particular skill. Okay, now what I do want to talk about now is finding the equation of lines that are parallel or perpendicular to other lines. So to do that, we have to make use of the fact that parallel lines, because in this case we're going to be finding the equation of lines that are parallel. Parallel lines have the same slope. Okay, so parallel lines they have the same slope. Okay, so remember what I need to write the equation of a line. I need a point and the slope. Well, I have the point that the line I'm looking for passes through, but I don't know the slope. But I do know that it's parallel to this line. And if I can find the slope of this line right here, then that's going to be the slope of the line I'm looking for. So my first step is to find the slope of the parallel line. So let's go ahead and convert that to slope-intercept form. So I have 2x minus 3y equals 5. Let's get the x on the other side of the equation. A minus 3y is equal to a negative 2x plus 5. Now then I'm going to divide by the negative 3 so that the y is alone. That would give me y is equal to a negative 2x all over a negative 3 plus 5 over a negative 3. So finally, y is equal to 2/3 x minus 5/3. Now what I'm looking for is the slope of this parallel line. And here's the slope of the parallel line. So that means that my line must also have a slope of 2/3 because the slopes are identical. So I know my line has a slope of 2/3. The point that it passes through is 2, negative 1. So let's plug those values in. Y minus y1 is equal to the slope, x minus x1. Y minus the y point, which is a -1, so minus a -1 would be a +1, is equal to the slope times x minus x1, and here's the x1 point too. So distributing, y plus 1 is equal to 2/3 x. 2/3 times 2, it's a -2 actually, would be a minus 4/3. And now I need to move this 1 over to the other side, so I would have y is equal to 2/3 x minus 4/3 minus 1. And 1, let's go ahead and simplify this further. So that would be y is equal to 2/3 x minus 4/3, and we need to find a common denominator for the 1. So that'd be 3/3. So my final equation is y is equal to 2/3 x minus 7/3. Okay, now let's talk about finding the equation of lines that are perpendicular. And we know that perpendicular lines have the relationship that the slopes are negative reciprocals. So if I know that one slope is 2/3, the perpendicular line must have a slope of a -3/2. Notice that I've taken the reciprocal of 2/3 and I've had to change the sign, so they're negative reciprocals. Now we have a couple special cases that we may run into when we're doing these lines, and one is that the horizontal or vertical line. And so if I have a horizontal line, its slope is going to be m equal to 0, right? That would be a line that is horizontal like this. It has a slope of 0. And the line perpendicular to it would be a vertical line, and it would have a slope that's undefined. So slopes of 0 and slopes that are undefined are perpendicular lines. Okay, so let's go ahead and do one of these. It says find the slope, or find the equation of a line in slope-intercept form that passes through the point 2, -1 as in perpendicular to this line, 2x minus 3y equal 5. And what we want to do is we're going to use this line, 2x minus 3y equal 5. We're going to find its slope, and then we know that we can find the slope of our line. So let's go ahead and take this 2x minus 3y equal 5 and change it to slope-intercept form. So I have a minus 3y is equal to 2x plus 5. Dividing both sides by -3, I have y is equal to a -2/3 x minus 5/3. Actually, there's a mistake here. Notice I used the same line as before. This should have been a -2x. So when I divided both sides by -3, that would be a -2 over -3x, and my actual equation would be y is equal to 2/3 x minus 5/3. Okay, so the slope of the line that my line is perpendicular to is 2/3. So my line is perpendicular to the 2/3 slope line, so actually the slope of my line would have to be the negative reciprocal. So that would be a -3/2. So there's the slope of my line. The point that it passes through is 2, -1. So let's go ahead and write the equation in point slope form, x minus x1. Y minus, now we have a -1, so that'd be plus 1, is equal to the slope, that's a -3/2, x minus the x point, which is 2. Y plus 1 is equal to a -3/2 x. Now a -3/2 times this subtract 2 is going to give me a plus 3, because it's going to be a negative times a negative. And now then I'm going to move this 1 over by subtracting it from both sides. So if I subtract 1, I get the equation y is equal to a negative 3/2 x plus 2. Okay, I'm going to show you one more skill, and I want to show you why. Well, actually, the first thing I want to talk about is why do we always convert these equations at the end back into slope-intercept form, even though I'm using point-slope form to find the equation. Well, let's take a look here. I have these two equations. Y minus 3 is equal to 1/2 x minus 4. That's this equation right here. That's point-slope. And I have a second equation in point-slope, and they do not look to be the same. But you can see that actually, well, after I do this algebra and I convert them into slope-intercept form, sure enough, those 2 point-slope equations actually are the same line. And so by converting it into slope-intercept, we can see that. So that's one of the reasons we always want to convert them. And the same thing here for these standard form lines. These standard form lines do not have the same equation. But after I do the algebra and I convert them into slope-intercept form, what I have is this equation and the equation from the second one are exactly the same. So in reality, these two standard form lines, the 2x plus 3y equals 6, 4x plus 6y equals 12, are actually the same line, but we couldn't see that in standard form. That's why we always want to convert those to slope-intercept form. Now here's one more skill that I do just want to show you, and we don't use it a whole lot. But let's say that I wanted to actually convert a line. After I got done and I have this equation of a line, I wanted to put it into standard form. We don't do that very often, but let's say I wanted to. Here's the technique we would use. Okay, so here I have a point slope form. Let's go ahead and get that into slope-intercept. So we would have y minus 3 is equal to a minus 1/4 x. This minus 1/4 times the subtract 1 would give me plus 1/4. Alright, so now let's try to move. Remember, standard form has all the x's and y's on one side and a number on the other. So let's go ahead and do that. Let's take and let's move this negative 1/4 x over to the other side by adding 1/4 x to both sides, and I would end up with this equation. Now then, I need to move this, wait a second, I left a little piece out there. Okay, let's try that again. So what I'm going to have is 1/4 x plus y minus 3 is equal to 1/4. Now then I will add 3 to both sides. And what I'll end up with is I'll end up with 1/4 x plus y is equal to 3 and 1/4. Now for this problem, I'm going to want to have everything in improper fraction form, or I want this mixed number to be an improper fraction, so I'm actually going to rewrite it as 1/4 x plus y is equal to 13/4. Now we learned a skill earlier, and that was how do I get rid of denominators as long as I have an equation. And what we do is we multiply by the least common denominator of the denominator. We multiply both sides by that number. So what I would do is I'm going to multiply this side by 4, and I'm going to multiply this side by 4. When I do that, this 4 will distribute in. It will multiply by the 1/4 x, giving me 4 over 4 times x. So that's just going to be x. The 4 distributes to that y, giving me plus 4y. And on the other side, Those 4's will cancel, giving me 13. And so what I have is the equation now converted to standard form. To finish this lecture off, I'd like to talk about the situation when we actually trying to find the equations of lines that are perpendicular or parallel to vertical and horizontal lines, because those cause us a lot of difficulty. So let's take a look at this first example. We're going to find the equation of a line that's perpendicular to the line that passes through the points 2, 4, and 2, negative 6. So we want to find the line that is perpendicular to the line that passes through those 2 points. Okay, so first thing we got to do is find the slope of those 2 points. So if we subtract the y's, that would be the slope would be equal to a negative 6 minus 4 all over 2 minus 2. I'm going to get a negative 10 all over 0. So we can see that this line has a slope that's undefined. And my line is perpendicular to that line. So if my line is perpendicular to that line, it's going to have a slope of 0. That's my line. And it's going to be a horizontal line. So if I have a horizontal line that is perpendicular to this line, it's got to be passing through one of those 2 points. So actually I left a little piece of off of here. So if it's passing through these 2 points, I would actually need another point that my line passes through. So let's say that my line passes through the point 2, 8. So I know that my line is perpendicular to this line with the points 2, 4, 2, negative 6. So I already showed that my line has to be a horizontal line passing through the point 2, 8. And if it's a horizontal line passing through the point 2, 8, let's think about that. 2, 8 would be like, say, up here. My line's a horizontal line passing through that point. It's got to be the equation y is equal to 8. For the last example, I want to do another one of these horizontal and vertical lines. And so what we have is we need to find the equation of the line that passes through the point 2, negative 3. So the line I'm looking for is passing through the point 2, negative 3. And that line is perpendicular to the line that's passing through the points a negative 4, 5 and negative 2, 5. So the first thing I need to do is find the slope of that line that it's perpendicular to. So let's do the slope. So I have 5 minus 5. That's the difference of the y's, and the difference of the x's is a negative 2 minus a negative 4. So I have 0 all over a negative 2 plus 4, 0 all over 2. And in this case, I have a slope that is 0, so this line is horizontal. And I am perpendicular to that line, so my line must actually be a vertical line. And it's passing through the point 2, negative 3. So think about this. If I have a line that's passing to the point 2, negative 3, and it's a vertical line, that line must have the equation x equal to 2.